Okay, now we're going to look at how to graph logarithmic functions. Before spring break, we had a look at what a logarithmic graph looks like, and so this is new to most of us. This is what a logarithmic graph looks like. This is my xy axis. Y, x. A log graph looks like this. It has, instead of a horizontal asymptote, it has a vertical asymptote at x is 0. Instead of a y-intercept, it has an x-intercept at 1, 0. And it hugs the y-axis right here. And then it goes like this. This is the look of a logarithmic graph. F of x is equal to log base A of x. And this is for where the base A is greater than 1. They all look like that. So on the sheet that we have, they ask us to graph a few different graphs. The first one is this, f of x, number 1, graph f of x is the natural log of x. So before spring break, we talked about what ln meant, and we learned that ln of x means the log base e of x, and we also know that e is a number that's about 2.71. 2.71 is bigger than 1. So natural log of x fits into this same category, so this is basically the graph of the natural log of x. So I'm just going to go ahead and put that up here. Let's replace this. This is basically what the natural log of x graph looks like. It's got this vertical asymptote. It's got this x-intercept. The domain of this guy is from 0 to infinity. The range of this guy is from negative infinity to positive infinity. So that is basically what the ln of x, the log base e of x graph looks like. Okay, that's number 1 on our sheet. Let's see. What else did they say? Domain, range, x-intercept. It said y-intercept. It doesn't cross the y-axis. So we'd say there is no y-intercept here. There's none. It talks about a horizontal asymptote. Excuse me. There's no horizontal asymptote for a logarithmic function. All right. So let's look at it says number 4 on your sheet. Actually, this says number 3 on your sheet. So we'll just go with it. We're supposed to look at 4a. The numbers are kind of weird, but 4a says, state the transformation, domain, range, and vertical asymptotes for the following functions. And so for a, it says f of x is equal to -3 plus the natural log of x. Okay. So what are they asking us to do here? Well, there's only one thing that's changed from our basic graph of the ln of x, and that's this -3. This is a vertical shift. Most of the time we talk about a vertical shift being tacked on the end. They put it in front. This is the same thing as the natural log of x -3. So this is going to be down 3. That's what we're looking at. So if this is our xy axis, the origin right here, this point gets shifted down 1, 2, 3. That's all that's happening here. So if normally there's this x-intercept to the right one, there's that point. If I got shifted down 3, then right here, if I go right 1, that's where this point's going to be. The vertical asymptote didn't change. It's still right here at x is 0. And so it just got, our graph kind of got shifted down. That's all that happened here. That's what this guy's going to look like. So the domain is still, is still 0 to infinity. The range is negative infinity to positive infinity. This is the vertical asymptote. And the x-intercept, I'm not going to worry about the x-intercept for this one. It's right there. What you do is you let y equal to 0 and solve. If we needed to do that, we could do that. We could say, okay, y is f of x. So we'll say when is 0 equal to -3 for natural log of plus the natural log of x. We need to learn how to solve an equation for that, exponential equation, so, or a logarithmic equation, and we're not ready for that. So just don't worry about where the x-intercept is on this one. It's fine. How about b? Let's look at b. B says this, f of x is equal to the natural log of x minus 2 plus 3. This is a horizontal transformation. It's in there messing with the x. It's the opposite of what it appears to be. So this means we're going to go to the right 2. Plus 3 means we're going to go up 3. So right here, we go right 2, up 1, 2, 3. This is my new xy axis, so to speak. This is my, I'm going to just lay out my logarithmic graph. This is my vertical asymptote at x is equal to 2. I'll go to the right here to put that little point. That kind of just gives me guidance as how to lay out this graph. And this is what this graph's going to look like. The domain for this guy is from 2 to infinity. The range is still negative infinity to positive infinity. And I'm not worried about the x-axis. This is the vertical asymptote. Right there. That's what you'll be asked to provide for me. Okay, then let's do part C. C looks like this. Negative f of x is negative the natural log of x plus 2. What transformations are taking place here? This negative in front of the graph means a reflection across the x, and this plus 2 means up 2. So this is reflected across x, reflected across the x-axis. This plus 2 means we're going to get shifted, up 2. So this is the graph for this guy, for C. Across the x-axis means this is coming down here and this is going up there. That's one thing that's going to happen. So if we think about it, this is going to be the reflection. It's going to look kind of like that. But then it's being shifted up 2. So let's see. This is going to be shifted. This graph is going to be shifted up 2, up 2. And so this will still be this. It's going to be look like this. So this guy's going to look like this is 2, this is 1. Where is the vertical asymptote? It is still at x equals to 0. The domain is 0 to infinity. The range is negative infinity to positive infinity. All right, I think there's just one more of these we're going to do. D looks like this. F of x is equal to the natural log of x plus 3. What transformations are taking place? Only one. It is horizontal. It's in there messing with the x. It's opposite of what it appears to be. It's going to get shifted to the left 3 places. So here's my xy. My origin gets shifted to the left 1, 2, 3. That means this is my new x asymptote. Vertical asymptote, sorry, x is negative 3 is my new vertical asymptote. This is this little sort of point, and so my logarithmic graph is going to be like this. That's what the graph will look like. The domain will be from negative 3 to infinity. The range will be from negative infinity to positive infinity. And the vertical asymptote is x is negative 3. So that is graphing logarithmic functions and some transformations.